Hello everyone. Can you hear me? Can you hear me? If you can hear me, kindly indicate that yes, you can hear me. If you can hear me, please try to indicate that you can hear me. He has the link, is it?
Is it Esther's link?
No, Chinwewe. But it's open now, that's where it is.
I'm not teaching from there, I'm using my laptop.
Chinwewe. Chinwewe. Up. Please, if you can hear me, kindly just let me know that you can hear me. Okay, very good. Okay, very good. By the way, who was the first person? Okay, looks like from what I have here, Marianne is the first person to join today's class. Okay. Yeah. Okay, so secondly, I hope you guys can see my screen. Can you see my screen? If you can see my screen, say yes, you can see my screen. Okay. Very good. Okay, so today I'm going to teach us how to write the formula of a compound. After today's class, you can start bragging about becoming a chemistry student. At least you know something more than what many other persons do not know. Right? So we are learning how to write the formula of a compound. Okay, so now if you want to know, and it's a skill, so that's what this class is about. I want to show you the skill on how to write the formula of a compound. And let me say that this is the foundation, because as you continue, you are definitely going to be talking about compounds. You are definitely going to be talking about formulas, okay? And that is a must. So now for you to know the formulas of a compound, in order for you to know the formula of a compound, there are two things that you must remember. Okay, two things. or three things. First of all is that you must know the symbols of elements. Okay, and arrange them in the periodic table. Don't worry, we are going to talk about what the periodic table is. Okay, or even if we don't talk about, to arrange them in the periodic table. Then number two, we must know their valences. We must know valences and radicals. We must know valences of elements, or what we call ions. Then number three, we must know the third thing we must know is radicals. We must know about what? Radicals. Okay, so those are the three things that we must learn. The first one is that you must know something about symbols of elements and how to arrange them in the periodic table. In the second one, you must know valences of elements or ions. Okay, let me say you must know. I omitted know. You must know valences of elements or ions. Then the third thing you must know is about radicals. So the first one, you must know symbols of elements and how to arrange them in the periodic table. Secondly, you must know about valences of elements or ions. Please remember. Then thirdly, you must know something about radicals. So if I am able to show you guys these three things, then we are good to go. Does it make sense? If you understand what I just said now, kindly state it that yes, you understand. And let me say this, those of you that are in the first group, paid group 1, this is your class. Once I say batch A, you know that this is batch A. Okay? So if you understand the things I wrote down, kindly indicate. Say yes, I understand. Don't worry about asking me questions. I just need to be sure that you guys know I've seen what I've written. Okay, so very good. Now let us start with how to write elements. I've shown you guys that before, but let's do it again. Excuse me. Okay, so just like I mentioned, every student must know the first 20 elements. And I'm going to write them here. So let's write it again. I've done that before, but let's do it again. First 20 elements. And let me say this, the same way when they call you, you are able to remember your name. The same way when you are called upon and you are able to remember your name, that's the same way whenever they call you to state the first 20 elements, you should know, you should state it. It's a must. As a matter of fact, you are supposed to know the first 30 elements. But because you are in because we are just beginning, we will limit ourselves to first 20 elements and also how to arrange it in the periodic table. But this is a must. I'm just trying to let you guys know that this is a must for you to know. Okay, so let me write down the elements. The first one we know is hydrogen. And I think in the other class, I also showed you guys how to remember it. We have hydrogen, the first guy. The symbol is H. We have helium. The symbol is He. We have lithium. The symbol is Li. We have beryllium. The symbol is Be. We have boron. The symbol is B. We have carbon. The symbol is C. Okay. We have nitrogen. The symbol is N. We have oxygen. The symbol is F. We have fluorine. Sorry, oxygen is O. Fluorine is F. Then we have neon. Neon, the symbol is Ne. Okay. Then we have number 11. We have sodium. Sodium is Na. Number 12. We have magnesium. Magnesium is Mg. Number 13, we have aluminium. Aluminium is Al. We have silicon. Silicon is Si. 15, we have phosphorus. Phosphorus is P. Number 16, we have chlorine. No. After phosphorus, we have sulfur. Sorry. We have sulfur. That's S. Number 17, we have chlorine. That's Cl. Number 18, we have argon. That's Ar. Number 19, we have potassium. That's K. And number 20, we have calcium. That's Ca. Okay, you can see that I'm taking the stress to list it all out again. I can see my video is blocking something, but yeah, so these are the elements. When you have gotten to that point, you can tell me so I can scroll it up. Okay, but these are the first 20 elements. Okay, these are the first 20 elements, and it's very important that you know them. Now, if you remember, in the last time I showed you guys something to use to remember them. He has light brain but cannot offer full 9 subjects. Mr. Abbott's stupid physics students come and practice chemistry. Okay, 18 to 20. Okay, that's it. 18 is argon, 19 potassium, then 20 that one. Very, 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 very important. Very important. Okay. So now, before I continue, I want to say this. If you notice, some of the symbols, of the names, the symbols is derived from the name. For example, I've shown you guys this before, so no, phosphorus is just P, not pH. pH means something else in chemistry. Please let me answer a call. Please, you guys should give me a second, okay? I need to sort out something. Just give me a second. I removed the volume intentionally. Give me a second. Okay, I'm back now. Okay, so if you can hear me, kindly state that you can hear me. Kindly state that you can hear me. I muted myself earlier. I did that intentionally. So kindly state that you can hear me. Hello, I'm waiting for your responses. State that you can hear me. Now, I was trying to say something earlier that some of the elements, if you notice, they don't really look like their name. This is what I'm trying to explain. Some of the elements do not exactly look like their name. For example, look at neon. You can see that this is coming from, Ne is coming from the spelling. Fluorine, you can see that F is coming from the spelling. Oxygen, you can see that O is coming from the spelling. Nitrogen, you can see that N is coming from the spelling. Can you see that? Now, but all of them are not like that. A good example is like sodium. The reason why sodium is Na is because it was a Greek person that discovered sodium. So this Na comes from the Greek name of sodium, which is something like natrium. And that's the same thing with, let me see, which other one again? I think that's about the only one. Okay, yeah, potassium. Potassium K. This K come from another Greek name, right? Yes, so that is why their symbols are not like that. But if you notice, all others are from their names. Aluminium, Al, silicon. Yeah, you guys are getting it. Yes. So examples like sodium and potassium, they are coming from Greek names. That's the reason why you see them that way. Okay? That's very important for you to note. Now, the next thing I like to talk about is yes, gold too. Gold is correct, Brian. Gold is correct, okay? And so on and so forth. Good. So now the next thing I want to talk about, like I mentioned earlier, is arranging them in a periodic table. So this is the periodic table. Now, but for now, we are going to arrange the first 20 elements in a periodic table. The first 20 elements has 8 columns, or what we call 8 rows. This is 1, 2, 3, 4, 5, 6, 7, and 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 columns, 8 rows. Please don't forget. And has 4 periods. You have 1, you have 2, you have 3 and 4. You see that? That's very important. Okay, so from here now you see H, he has light brain but cannot offer full 9 subjects. Mr. Abbott, stupid physics, students come and practice chemistry. Don't mind me, from secondary school I've always sang that song. Now I want you to understand something. Yeah, iron is correct. Iron is also true. Iron is from the name ferret. That's why it is Fe. That's the Greek name. Gold is from the name aurate. That's why it is Au. So you are right. So let's focus on what we are doing now. Okay, I'm glad that you guys are following. Okay. Okay, very good. No, zinc is not part of it. So, in this periodic table now, I will call these guys here group 1 elements, group 2. Now, please notice that I wrote hydrogen here in group 1, and I wrote helium in group 8. There is a reason. So, after hydrogen, jump to group 8. Don't worry, you don't need to know much about this. As we continue, you will get to learn a lot here. So we have group 3 here. We have group 4. We have group 5. We have group 6. We have group 7. We have group 8. Then period 1, period 2, period 3, and period 4. Okay, so this is exactly what we have. Are you seeing that? 8 groups and 4 periods. Now, I want to be sure that you guys understand it. So you start from number 1. The first one will go to number 1, then you go to number 8. You go to the 8th group to start number 2. Then you continue that way. You continue that way. Okay, if you understand it, let me know. Say yes, I understand, I understand, I understand. Yeah. So while you are saying yes, you understand, I want to remind you that you are supposed to write out. You are supposed to write out. You are supposed to know each name, practice each name. In fact, throughout this week, practice the name. While you're writing, you understand. Right? Practice the name. Okay? Genesis Afoke, what is the problem? So I'm waiting for your responses before I continue. Okay, very good. Okay, Brian, that's good. Okay, good. For those of you asking for test, the test will come up next week. Okay, if you're asking for the test will come up next week. Okay. Okay, very good. So I'm glad that you guys understand. Yes. So now, this is the first thing. Remember I said that there are 3 things. There are 3 things. The first one is that you must know the symbols of elements. And you must also know how to place it in a periodic table. And that's exactly what we have just done now. Now we need to move to the second one. The second one is that we must understand the concept of valencies. We must understand the concept of valencies. We must understand the concept of valency. So I want to say something about valency. Now, you can write that valency is the combining power of an element or radical. So valency is the combining power of an element or radical. That means valency is what determines how an element will combine with another element. Okay, that's what valency does. If, for example, I have sodium, I have sodium and I have chlorine. Sodium will combine with chlorine like this. That's why we call it sodium chloride. But if I have magnesium and I have chlorine, it's not going to be, magnesium chloride is not NaCl. Magnesium chloride is actually MgCl2. If I want to combine aluminium and chlorine should be written as AlCl3. So you see now that there is a problem here. Why is it that sodium can only combine with only one chlorine? Magnesium can combine with 2 chlorine. Aluminium can combine with 3 chlorine. The simple reason is because of valencies. Everybody's valency will determine how it can combine with the other person. Okay? I hope that is making sense. I hope that is making sense. If it is making sense, kindly state that it is making sense. Okay, so now let me say this. Sodium, which is Na, please listen again. Sodium, which is Na, is a metal. Magnesium, which is Mg, is also a metal. Aluminium, which is Al, is also a metal. Now, if sodium was combining with chlorine, it will be written as NaCl, that is sodium chloride. If magnesium combines with chlorine, it is written as MgCl2. If aluminium is combined with chlorine, it will be written as AlCl3. So you will note why the reason why sodium chloride, magnesium chloride, aluminum chloride are not written the same way is because of valency. It simply means that sodium, magnesium, and aluminum have different combining powers. They have different abilities. For example, in real life, some people cannot manage more than one woman as a man. I'm sorry for this example, but you know, this generation is nonsense people used to understand. Some people is one woman at a time. Then some people, one is not enough, they like 2. They have power to manage 2 women. Some people have power to manage 4 women. So different people have different abilities. That's the same way every metal has its own combining power, has its ability to combine with the other elements. And I'm going to give you examples now. Okay, so but I'm just trying to explain something here. Valency is the combining power of an element or a radical. That means valency tells us how an element can combine with other elements. That's what valency does. Valency tells us how an element combines with other elements. Okay, Enyoma, I think you should just follow my class. This is not time for that. Ask questions at the end of my teaching, please. Okay, so now I want to write valencies of elements. For example, watch. This is elements, and these are their valencies. So look at this. The group 1 element, that means the ones in group 1, their valencies are +1. All those elements in group 1 like hydrogen, sodium, potassium, lithium, all of them, their valence is +1. Group 2 elements. Group 2 elements are things like magnesium, calcium, beryllium, all of them, their valence is +2. And remember, +1 because they are in group 1, +2 because they are in group 2. That's the reason why I showed you guys the periodic table, so that even if you forget their valencies, the periodic table can show you so that you can remember. For me, in those days, when I go to write chemistry exams, the first thing I do is to write the periodic table. That's the first thing I do in writing. I write the periodic table because the periodic table helps me to remember many things. It can help me to remember valency. It can help me to remember, many other properties of elements. Okay? I want to believe that I make sense by that statement. Now, the next thing I want to say, okay, the next one is group 3 elements. Group 3 elements, the valency is +3. So you have something like aluminium and boron. Group 4 elements. Now, this one here, you have to be careful. Group 4 has 2 valencies. Group 4 has 2 valencies. Group 4 can be +2. Sometimes it can be +4. Please note, group 4 element has 2 valencies. Sometimes it can be +2 and sometimes it can be +4. So there are some elements that have more than one valency. It is allowed. Listen again. I feel like drawing my ears. Some elements have more than one valency. But generally speaking, group 4 elements have 2 valencies. Sometimes they can be +4. Sometimes they can be +2. Then, if I continue with the other one, like group 5 elements. Group 5 element is -3, -3. Group 6 element is -2. Group 7 element is -1. Please notice the pattern. Then of course, we will not write group 8. Group 4 element are things like carbon, silicon, lead. These are the important ones. Group 5 element are nitrogen and phosphorus. Group 6 element is oxygen and sulfur. Group 7 element, things like chlorine, bromine, iodine, fluorine. All of them are group 7 elements. Their valencies are -1. Okay, so these are valencies of element. Let me reduce my board so that you guys can see it at once. So these are valencies of elements, and you should take them very seriously. Okay, now some of you may want to ask the question, why is it that some valencies are positive and why some are negative? That is a very important question. Now, those ones that are positive, they are usually metals. Not all of them, but most of them are metals. In fact, almost all of them are metals. While the other ones, group 5, group 6, and group 7, are non-metals. So, in forming a compound, that's why a man cannot marry a man. That is why a woman cannot marry a woman. It does not make sense. It is a man and a woman. So, the same thing in science, you cannot form a compound by using 2 metals. It's very wrong. You cannot come and tell me something like this. You write something like this. The name of this compound is sodium magnesium. happening? Give me a second, please. Okay. Hello. So, for blessing, you're asking about group 8. Group 8 elements do not easily form compound because their valency is 0. Their valency is 0. So group 8 elements are not reactive. They hardly form compound. You will hardly see a group 8 element in a compound. That's why we don't write them. Are you seeing that? That's very important. So, like what I was saying before, you cannot write it. You can't say this name of this compound is sodium magnesium. Somebody is supposed to knock you from the back. Because sodium and magnesium cannot form a compound. The both of them are metals. So a compound is usually formed. Now please listen. A compound is usually formed between a metal and a non-metal, or between two non-metals. Between a metal and a non-metal, or between two non-metals. Please, that is the reason why. And whenever you form a compound, one must be positive, the other one will be negative. It's positive and negative, then they can come together to form neutral, something that is neutral. Positive and negative come together to form something that is neutral. Yes, group 8 elements are called noble gases, rare gases. They are not reactive. In fact, you can even call them inert gases, INERT, because they are not reactive gases. Very, very important. Okay. Yes, group 8 element has a valency of 0. Group 8 element has a valency of 0. Okay, if you're done writing, let me know. Just state it that you're done writing. Once you're done writing, just state it. Okay, Genesis is done. Any other person? Once you're done, just state it that you're done so I can continue. Okay, Gina says almost. Okay, Lucas is done. Sorry, who is Lucas? Can you identify yourself? Okay, Enyoma is done. Okay, I'm waiting for others. Oh, Lucas, you joined yesterday. You are meant to be in the other group, not this one. But it's fine as long as you're understanding, that's okay. But send me a message after the class. Okay, so I'm going to assume that everybody's done. I'm going to assume that everybody is done. Give me a second, please. Okay, so now if you have an element A and the valency is X plus, and you have another element B and the valency is Y minus, it means that the compound is going to be written as AYBX. The compound is going to be written as AYBX to the smallest ratio. So that means their valencies will exchange. So Y will come down this way, X will come down this way. So a good example, let's say I have an element X, the valency is plus 2. I have another element Y, the valency is plus 3. If I want to write this correctly, the compound now, this guy and this guy, the way they can form a compound is by X3, Y2. X3, Y2. That means you need 3X to combine with 2Y. Do we understand that? Genesis, I thought we've addressed this. Anytime you see that my screen is blurry, it's not from me, it's from you. So just increase your resolution so that you can see clearly. Increase the resolution. I've shown you guys that before. Okay, do you guys understand this? Because I want to continue. Do you understand? If you do, say yes, I understand. Let me give another example. Let's say an element P has a valency of plus 2. Another element Q has a valency of minus 2. Because they have the same valency, it means that they need to just combine 1:1 like this. Remember, to the smallest ratio. Smallest ratio means that 2 can divide 2. 2 here 1, 2 here 1. So it will just be PQ. So this compound is PQ. I hope you get that. Good. Good. Darasimi, yes. Gina, good. Marian, which one is Can I understand the rationale behind your Enyoma understands, good. Okay, Darasimi understands, good. Okay, who else? I'm waiting. I'm waiting. I'm waiting. Okay, Stanley understands. Marian understands. Chinelo does not understand. Okay, the last one. Okay, so now, by right, if I follow the formula, this is supposed to be P2Q2, but 2 can divide 2 now. 2 here 1, 2 here 2. Remember, they say to the smallest ratio. It must be reduced to the smallest ratio. So if I have an element, let me say A, this one is, the valency is plus 2. Another element B, the valency is plus 4. I know that 2 can divide 4. I can still divide this in the smallest ratio. 2:4 means 1:2. So that means if the exchange valencies is going to be A to B. Okay, so that is how it works. To the smallest ratio, to the smallest ratio, to the smallest ratio. So now I'm going to write names of compound, and all of us are going to write it together. We would write the formula together based on our knowledge of valencies. But this is how valencies work. You must, when you know the valency of one element, the valency of another element, then you can just exchange their valencies, and that will give you what we are looking for. So let me start with this, more like a class work. Let me say, write the valencies write the formula write the formulas of the following compound. Number 1, two, 3, 4. Okay, you guys should write this down. Let us name them. Let us write the formula of the compounds. Okay, give me a second. Give me a second. Write these things down, then we'll come back together. Okay, I love what I'm seeing. I love the responses I'm getting. Okay, that's beautiful, beautiful, beautiful. I love what I'm seeing, even though there are some mistakes, but that's fine. I can see some mistakes, but that's fine. That's fine. Okay, so let's do them together. Let's do them together. Now, so please follow me accordingly. Sodium is +1, that's the valency, is a group 1 element. Chloride is -1, is a group 7 element. So sodium chloride +1 and -1, that's why it's written as NaCl. Magnesium, the valency is +2 because it's a group 2 element. then chloride is -1. So if I want to write magnesium chloride, if they exchange their valency, it's going to be MgCl2. Now aluminium is Al is 3 plus, chloride is -1. So aluminium chloride is AlCl3. Aluminium oxide, aluminium is +3, is a group 3 element. Oxide is -2, is a group 6 element. If you want to remember the negative values, you can just say subtract it from 8, like 6 minus 8 is -2, 5 minus 8 is -3. 7 minus 8 is -1. That's how I do. So aluminum oxide now, this will be Al2O3. So 2 will come here, 3 will come here. That is how you write aluminum oxide. Can you see? This is how you write aluminum oxide and no other way. Okay? Now, potassium oxide. Potassium is +1. Oxide is -2. So potassium oxide is written as K2O. Potassium oxide is K2O. Okay? So calcium nitride is, calcium is +2, nitride is -3. So if I want to write the formula of calcium nitride, it will be written as Ca3, Ca3 then N2. So 3 will go for calcium, 2 will come for, so this is how you write calcium nitride. Are you seeing this? And I like the fact that many of you are getting the gist. Many of you are getting this. Okay, so that's calcium nitride. Then when we say magnesium oxide